Welcome back, Leo Lions. This is Mrs. Morgan with today's lesson on exponential functions. So we're comparing three types. We've talked about linear this year. Exponential is what we're getting into. And then quadratic comes later on in the year, but I'll at least introduce you to some of the things, features of a quadratic function. So first of all, let's just look at the difference between the three types of equations. So a linear function, we've learned that y equals mx plus b, slope-intercept form, will always form a straight line on the graph. So here we go. We could have a positive line, we could have a negative slope line, horizontal, vertical, anything that has a straight line is a linear function. What we're looking for in our equations, some examples, you may see it actually in that format, so maybe something like y equals, negative 2x plus 7. We know that's going to form a line. We could also see it instead of that y, sometimes we'll see it as a function, so f of x. If we could see it as just a number, so f of x equals maybe 4. That would be a horizontal line. We may see it, with a fraction in it, the x has to be as the numerator, so maybe something like x over 2. If you see the x variable with a power of 1, then we know it is going to be a linear function. So those, you'll see them in different formats, but as long as you have one x in that function or that equation, then it is linear. So there's our linear equation. An exponential function. So exponential, think exponent. We want the variable x to be an exponent. So the form for that equation is y equals a times b to the x power. So like I said, we're looking for the x is the exponent in the equation. So again, you're going to see it in a bunch of different ways, but that's specifically what we're looking for. On the graph, you will see this as a curve. So oftentimes we may see it something like this. That would be exponential growth. We may also see it going the other way. So something, and we'd see it maybe below that x-axis, but something like this. So exponential has a curve to it. Sometimes it looks like it levels out and then it takes a big increase or decrease. So there's an exponential function on the graph. And then last one, a quadratic function. Quadratic, like I said, we'll get to in greater detail in a future bundle. But what we're looking for here is the variable x has a power of 2. So if you see x to the second power, and again, these equations may be in different formats. It may not look perfectly like y equals ax squared plus bx plus c, but if you ever see x to the second power, then it is a quadratic function. And I'm going to keep it consistent there. On the graph, a quadratic function, since it's x squared, that means the positive number we put in and also the negative number we put in, it's symmetrical. So a quadratic function, that was not good, looks something like this. So we call that a parabola. And the quadratic function can be an upwards U like that. It could also be a downwards U. I'm just going to keep that one example on there. Okay, so those are what they look like on the graph, and those are the types of equations you're going to see. Now, over to the far right here, I'm going to zoom in. There are other types of functions. So if you ever see something like x cubed in an equation, x to the fourth, x to the fifth, anything higher than x squared, for now we're going to put that in another category. Absolute value, so if x is the absolute value, again, that's a different type of function. So those are some examples, and then also if you ever see x in the denominator, that will not be, maybe something like that, that will not, I'm going to take that back, because that could eventually be an exponential function. So I'm going to leave it there for the other category. Now, the tables, what we're looking for are patterns. Typically, you're going to have your x coordinates in increasing order. So I'm going to start with something like -1, 0, 1, 2. Remember, a lot of times we get to pick those, and then we figure out what the y value is, plugging it into the equation. But if we just have the picture of a graph, what we're looking for in a linear function is a consistent pattern, either adding or subtracting, no multiplying or dividing. So here, each time we are adding 2, so this is a linear function. So y values have a common difference. So we're either going to be adding or subtracting. And it has to be add or subtract the same number over and over in order to be linear. So that common difference in that one is +2, adding 2, okay? Now, next one, exponential. Think about exponents. They are going to increase a lot faster, a lot more rapidly than a linear. So again, I'm going to keep my x values just one apart from each other. The y values, I'm going to increase. So I'm going to do 0.5, and instead of adding or subtracting, I'm going to multiply. So if I multiply by 2, we get 1. And I'm going to do this over and over, and then 2 times 4, and it, oops, wrote down the wrong thing, times 2. So this would be 4. And you're going to see if you continued this table, you'd get 8, 16, 32. It's going to increase pretty fast. So in this case, the y values, or the y coordinates, they have what we call a common ratio. And a ratio, when we look for that, we are going to multiply or divide the same number over and over, okay? Then last one, a quadratic, little harder to find that pattern. And I'm gonna just keep all my values positive here. What happens here is you're gonna look at the table and notice that you can't really find a great pattern. So we actually want to look at the second difference. So let's look at the difference from 0 to 1, 1 to 4, and 4 to 9. But now, look at the second difference. So between 1 and 3, there's a difference of 2. Between 3 and 5, there's a difference of 2. So you look for a pattern, and if you can't see that great pattern of multiplying, dividing, adding, or subtracting, look for what's adding or subtracting over and over, and then look at the second set to see what's adding or subtracting. So in this case, the y values have a second difference that is constant. And again, in this one, we want to add or subtract over and over, no multiplying or dividing. So that's how you can look at different types of equations and identify them, different types of graphs, and also different types of tables to categorize